Our first speaker is Gareth McGraw from the Civil Aviation Safety Authority, CASA, Safety Management Systems and Human Factors. CASA has implemented an ANTS strategy, Associated Non-Technical Skills strategy, that they call human factors. We will hear about that and what CASA intends for the future, and the importance of ANTS to aviation safety culture in Australia. So I'd like you to welcome Gareth to the stand. Thank you.
Thank John, Bruce and Carolyn for inviting me here. I'm going to be talking about what aviation's been doing in the recent past and also into the future, and we're going to be in the future, with human factors and non-technical skills. Now obviously these are examples of the way our industry is going ahead, and really isn't meant to be an example of the only way to do it, just what's been found to be appropriate for our industry. So this morning we're going to review human factors and non-technical skills in aviation, exactly what we've been doing. We're going to discuss error risk and error management, HF and non-technical skills training in aviation, discuss the integration of human factors and non-technical skills with safety management systems. We see that as one crucial area to ensure that you've got appropriate training that actually has and achieves a positive safety outcome. Discuss the relationship of safety culture with effective use of non-technical skills, and then just draw some conclusions from all of that. So first of all, human factors and non-tech skills in aviation, a couple of definitions. Now these are out of our legislation, so we have some definitions next to some of our legislative requirements. So by human factors, we mean the minimisation of human error and its consequences by optimising relationship with systems, within systems between people, activities and equipment. That's a pretty standard definition that you'll see in many industries. And non-technical skills mean specific human competencies, including critical decision making, team communication, situation awareness, workload management, which may minimise human error. Okay, HF principles and their associated non-tech skills have been widely used in aviation for many years. Non-tech skills are the enabling skills which facilitate our crew resource management, threat and error management and maintenance resource management frameworks to ensure safe operation. Where do they come from? We talk about human performance, and for many years there's been an understanding that like any other component of a machine or technical system, the human component has performance limitations that will define the extent of its effective operation. That is, we all have limitations. We are all prone to error. No individual will ever be error-free in their life. So we say that, just like an aircraft, humans have a performance envelope. Now, relatively speaking, this envelope is quite well defined. But it must be taken into account in the design of our systems, equipment and operational procedures. The only problem is, unlike mechanical components which have a high degree of predictability to their performance characteristics, the size and shape of the envelope is specific to each individual. So while we've got a generic understanding, there's a high degree of variability within that for individuals, which makes human-centered design very difficult. So, the downside of human performance. There's a lot of statistics that are bandied around. Anywhere between 80 and 100% of major incidents and accidents have human error as a major contributing factor. This is hardly surprising considering that humans have been involved in the planning, design, implementation, maintenance, operation of any system. So they're going to be a contributing factor. But what often isn't understood is 100% of solutions are human-driven. A machine cannot operate or compensate outside of its design specifications as well as a human being. We state that the human element in any system is a supremely adaptable and effective problem solver that is often able to resolve situations with limited information. Again, the problem is we've got to make sure that those solutions are appropriate. One of the few funny slides I've got, well, one of the issues with that is from the other side of the fence, that chain will look fully functional and appropriate. And how often our system does the same thing. It will hide those deficiencies and major flaws. So, the really boring bit, legislation. What have we got in aviation at the moment? We've had some major additions to legislation. In the maintenance environment, we've we are in the middle of changing over. We've changed our licensing requirements and also the requirements for operation of maintenance organisations. So Part 66 is our licensing requirements. So for licensed maintenance engineers, they're required to complete a module on human factors as one of their basic subjects. Within Part 145 organisations, these are organisations that hold a certificate to maintain large, regular public transport aircraft and their components. They must ensure an understanding, an up-to-date understanding of human performance limitations and the application of human factors, and also understand the impact of human performance limitations. So in that way, they're having to make sure that the systems they use and the demands on their personnel are within the performance characteristics of those individuals. Within the operations side, for an AOC holder, an Air Operator Certificate holder, we have 2 orders. Now at the moment this just relates to regular public transport, so charter and GA operations don't have this requirement. But they must have a program approved by CASA to train and assess personnel in human factors and non-technical skills with the aim of minimising human error. Now this legislation has a very specific safety outcome statement, minimising human error. However, that can in itself be ambiguous. What do we mean by minimising human error? First and foremost, we look at error as a risk. Error has 2 values: a likelihood an error will occur during any given task, and the consequences of that error. These values are influenced by risk factors. Risk factors are, this is Risk Management 101, risk factors are conditions or circumstances that influence the value of one or both of the following components of risk. By breaking it down to a simple definition like that, you can start to apply management principles in order to minimise it and ensure that that doesn't happen. If anyone likes Farside, this is a live action version of a very good Farside caption. Now what we're talking about there is obviously situation awareness, and before we did state that it's a non-technical skill, yet there is a contention that it's actually an emergent property. You have accurate situation awareness due to the use of the appropriate use of non-technical skills. It's something that emerges. In itself may not be a skill. It's using other skills to ensure it's effective and appropriate. So, we're going to risk factors. Likelihood can also be called error potential. We call it that because everybody has error potential, the chance that an error will occur, and it's influenced by the attributes and experience of the personnel who will carry a task out. That is to say that any given task has certain demands, so you need to ensure that the performance characteristics of the individual fit the task demands. Also the environmental conditions, that's both physical and organisational, in which it must be carried out. So are we talking about confined space? Is it dark? Is it noisy? Also, is the pressure to produce? Has someone been given 4 hours to complete what is known to be a 6-hour task? So then we've got the underlying task complexity or demands. Again, are the tasks that have many complex steps with a large amount of information that you have to review. A task that is known to be safety critical, so one error can be catastrophic. And importantly, the resources required to safely carry it out. And are they available to the personnel? Do we have all the support equipment that's required? Is it serviceable? Is it easy to manage and maintain? The second risk factor is obviously consequence. Now, when we analyse the consequence of an error, we have to understand that once an error has been committed, its ultimate consequence will depend on the nature of and the controls within the system in which it was made. Now, an example is a typo. If you write 100 instead of 10 when ordering paper towel, you'll get an oversupply. However, writing 100 milligrams instead of 10 milligrams when noting dosage for medication on a patient's chart may be fatal, yet both are essentially the same error. So a lot of the time what we do is the way we manage error is just due to the consequence. We don't consider the mechanism by which it occurred. We just manage it according to the consequence. So in aviation, we have comprehensive controls in place to manage error that have produced largely a very safe industry. But when things have gone wrong, many investigations have shown that these defences were not working as intended. So we have what we consider to be adequate defences in place if they're used correctly, if they're working correctly, yet they don't seem to be. So what we look at then is other influences, and these influences are often what we call human factors. So then we move into error management, which involves a framework to effectively target the two components of risk, with error reduction seeking to reduce likelihood, and error capture and tolerance limiting their consequence. Again, we've used the definition of error to start looking at what we can manage. Now, within aviation, my background is aviation maintenance, and it's procedurally driven, and within those procedures are error management functions. And often we find that when they don't work as intended, it's because people don't understand what the underlying function is. So maintenance inspections, they're an error capture function. They're there to identify errors early, once they've been committed, and to correct them before they become consequential. Yet when you ask people, why do we have inspections? Because it's a legislative requirement. It's a compliance issue. They don't look at the function behind it. Now, there's some figures put out a few years ago that about 40%, when an error had been committed, there was a study done, when an error had been committed, about 40% of those errors were captured by inspection. Now, knowing what the function of inspection is, you can then ask, is that an effective control? Obviously not. 40% has been captured, less than half. So then you go back and you talk to people as to why it is they weren't capturing errors. Because they're failing to understand what the inspection's for, and they're going into the inspection with a mindset that, I'm just, something will pop out, yeah, I know my best troop's done it, I just have to have a quick glance over it. Not, I'm here to ensure that if an error has occurred, and it may well have occurred, we know that errors do occur, that I've got to find the error that is here. So understanding what the function is, we can then get people to use our controls more effectively and understand if they're deficient. So it is, in essence, error risk management. So, the application of non-technical skills, human factors principles and non-technical skills, is intended to work within whatever error management framework you put in place to also reduce the values of one or both of the risk components. So they are in themselves risk controls. By understanding that, we can apply pretty basic principles to them to see what we need to do and whether they're working properly. So in essence, HF training in aviation should improve employees' awareness of their own limitations and the influences of human performance on error potential, improve their awareness of the possible systemic influences on error potential, it's clicking over. Improve employees' awareness of the organisation's error management system components of their functions, to know why they're doing something, not just what they've got to do. That better understanding of the underlying principle will help the system to work better. And in doing so, provide tools and techniques that enable employees to utilise their error management system to its fullest potential. Again, investigations have shown that we'd had robust controls in place. They just didn't work properly. What degrades them? Normally the influence of human factors. What can prevent that a little bit? We go into a bow tie and we look at escalation factors. They're human factors. We look at escalation controls, and they may well be your non-technical skills. So we enable employees to identify and mitigate individual influences to error potential. That's the core of non-technical skills. And also give them a better awareness to identify system and error management functions that are deficient, and a language to use. So when an employee talks to management, they don't say, oh, you know, well, we can't do that, and it sounds like I don't want to. There's an explanation of why they can't do that management understands. It's not I don't want to do it, I physically can't do it the way you're asking me to safely. It takes it out of emotive language into more objective language. And specifically as well, to equip employees with the skills and knowledge to identify ways to improve the system. Virtually all of your solutions and improvements will come from the coalface. They know the risks, they know the problems, and generally we know the solutions. What we do find, though, is people employ solutions without realising some of the other risks they may introduce. So a collaborative way is to get the solution from the coalface and then do a critical review away from the pressure of production. To say, that's excellent, however, we may need just to modify it slightly because these risks are being introduced. Big example in aviation was an accident many years ago when an aircraft lost an engine. It peeled off the wing, unfortunately, took some flight controls with it, and the aircraft crashed and killed everyone on board. That had come about because of a novel solution for changing engines. Instead of dropping the engine off the pylon and then having to go through so many different steps, they were using a forklift to drop the engine and the pylon together and saving an awful lot of time. However, they were stressing fuse bolts in there that they didn't realise, and they fractured. So they'd introduced a risk in trying to do a good job. They were genuinely trying to do a good job. But they didn't realise or even think they were increasing risk, but they were. So, what should NTS do? Target your risks. And how should it do it? Again, we go back to basic risk management. As with any risk management process, resource allocation is commensurate with a high risk level. So you've only got limited resources, so you want to get the best bang for your buck. You use your risk management process to identify the areas of increased risk. So these may be the tasks without a lot of tolerance for error. There's an example with rotary wing, where there are certain components that there is no tolerance. Some of the linkages in the rotor head, if they disconnect, the aircraft is going to crash. And there was an accident a couple of years ago where a split pin was left off a servo linkage, and the nut walked off, disconnected, and the aircraft becomes uncontrollable. So there's a very high-risk task. So you would identify that, and your resources would go towards addressing those high risks. So where does NTS come in? The value of good HF and NTS training provides personnel with the ability to better analyse the risk levels and identify HF influences of specific tasks and operation. But a poorly thought out program may not provide a risk reduction outcome. It will simply be an isolated training course with no functional relevance. This is training for training's sake. This is the compliance mentality. What we've often seen in aviation is certain roadblocks. Human factors knowledge can be difficult to translate into an effective program to minimise human error in an organisation. It can be very academic. We'll just talk through human performance limitations and give a few examples of incidents and accidents, but don't relate that to the environment in which it's going to be used with specific examples and workshops. To be effective, a high level of understanding of human factors and non-technical skills is required during the development, and there are a limited number of people, especially even in aviation, to produce these courses. If done badly, the personnel it's delivered to wish they could get those 2 or 3 days back because they can't see the relevance or validity of the training. It's highly academic with no application whatsoever. As a maintainer, if someone starts giving me a 2-day course and I can't see the relevance, I will forget that straight away and have a negative learning effect. I won't want to listen about anything to do with HF and non-technical skills. And what we do see a lot, it's seen as a box-ticking exercise. There's a requirement, and here's a course that roughly fits it. But it has no outcome. It's wasted training, it's wasted time, it's wasted resources. The way we've tried to go about it in aviation is to look at integrating it with safety management systems, to use those functions in the safety management system to drive the training. Instead of it simply being a training course to meet, a generic training course to meet regulatory requirements. John was saying before that sometimes they have a course and people go down and make mistakes. We've had maintenance organisations where we've done an investigation and we've gone through, look at the causal factors, and we've said, don't you cover this in your courses? Yeah, we do. But for some reason they just hit the shop floor and they just revert to type. Well, that's because you've changed nothing else. Nothing else at all. You've just delivered a training course in isolation with no real relevance, with no real use for the people. Yeah. So hazards and their non-technical skills should be identified and coordinated through your safety management system. This is consistent with the identification and treatment of other hazards and risks. And I've got a little diagram here called the turbo model. This is just indication of the sort of process that can be used. Where you start off with an initial course, people go out to the workplace, they start using it, they start identifying hazards, or through your evaluation you see if it's working or not, and then that's fed back in through. But the process uses the safety management system. But first and foremost, then we need to ask about safety culture. Safety culture can be very simply defined as an organisational commitment to safety at all levels of operation. Is it important, though, to the use of your safety management system in developing non-technical skills? Well, the acceptable and unacceptable behaviours of individuals, groups and organisations are a visible indicator of the underlying safety culture. Now, these behaviours will include the use of non-technical skills. Safety culture is a very powerful driver for safety behaviours. Never underestimate the desire to conform to the norm. And it will drive both good and bad norms. So these organisational individual safety behaviours have a direct effect on safety outcomes. This has been shown through many safety investigations. Many authors have listed safety culture as an essential ingredient to improving safety and safety management system performance. And here's one quote from Skybury, which is an online resource, that organisations need both an SMS and healthy safety culture in order to achieve acceptable performance. In aviation, the importance of safety culture is widely accepted, and the development and measurement of a healthy culture is actually one of the requirements in legislation. However, it can be very difficult to change, very difficult and slow to change. Estimates are between 5 and 7 years often to effect a positive change in safety culture, and you can destroy it very quickly. So HF courses usually focus on desired attitude and behaviours that contribute to a good safety culture, but they just discuss it. Again, it can be very academic. There has been an argument made by James Rees and Alan Hobbs that an isolated assault on attitudes, such as through training, may not be as effective as also changing practices in line with good human factors guidelines, so acting, doing and getting results. So in discussing that, including the use of relevant, practical, non-technical skills in work processes can be an integral part of the use of good HF guidelines that affect a positive shift in attitude to safety and also in an organisation's underlying safety behaviours. So instead of waiting for a good safety culture to try and enable non-tech skills, use technical skills to enable the safety culture. This means that while a positive safety culture may well be an enabler to the widespread use of effective non-tech skills, facilitating their use with training, management commitment and changes in work practices will have an effect on producing a positive safety culture. Now, the big word there is management commitment. The first time, again, that any person in senior management in aviation gives someone Half the time that we know is required to do a job is the first time you'll see workarounds, poor safety behaviours, and a slide in safety culture. And that will be driven from management. You have to walk the walk, you have to walk the talk. You have to get out and ensure that people are given the right resources and you allow them to use those non-technical skills and listen to them. That's what we've found. So human factors contains a broad field of knowledge that can be difficult to apply in a particular context. That's a difficulty. That's why we often see non-tech skills courses that produce no visible safety outcome. And it can be difficult to translate. And we've had that problem time and time again in organisations. And it makes them very disillusioned and they can't see the point of the legislation. They think it's just legislation for its sake. So first of all, operators, we find, need to effectively apply error management strategies and then incorporate their non-tech skills. It can't be in isolation. They've got to know how they're managing error. They should integrate their human factors principles with a safety management system. And then that will allow HF to be in all aspects. So human-machine interface, operational processes, and the development of their non-tech skills. And in doing so, well-defined and appropriate NTS training will help to produce a positive safety culture.